Hello everyone, welcome to week 1 of BME Mechanics. We're going to do a sample problem on Cartesian vectors, chapter 2, problem 30 from the textbook. So, the picture is horrible, I know, but the problem states, the magnitude of the resultant force acting on the bracket is to be 400 newtons. Determine the magnitude of F1 if phi equals 30 degrees. So phi is this angle right here, so they tell us this is 30 degrees, they tell us this is 40, and we don't know what F1 is, but we do know F2 and F3, and we know the total F resultant is 400. So the way I start is I look at all my angles. I know pretty much all my angles besides this one over here. I redrew it just so we can look and focus on the forces instead of everything else. So we don't know this angle, so that's the first step. We need to solve for it. For this we require trigonometry, so if you don't remember your SOHCAHTOA, refresh on it. Here we go. So let's start with looking just at this portion of the problem. How can we find this theta here? Okay, so they give us a 3-4 triangle right here, but what it basically means is that this triangle on this side, if there was another one, would be a 3-4-5 triangle. Because that's a 3-4-5, it means that this triangle is a 3-4-5 as well. So this is our hypotenuse, it's 5, this is 4, and then this would be 3. So we can solve for theta right here, by basically doing the arctangent, or whatever you want to do. You can use the sides to find theta. So I did tan theta equals opposite adjacent. So opposite adjacent. So tan theta equals 3/4. The arctangent of 3/4 equals theta. So I found theta to be 36.87. So now I know what this angle right here is. And I know pretty much all of my angles, so I can proceed. So I'm going to start by decomposing all of the forces into Cartesian coordinates. So we start with F1. So F1 equals its x component plus its y component. So in order to find the x component, we do cosine of 30. That will give us this section, and in order to get the y component, we do sine of 30. That'll give us this section. So F1 cosine 30 plus F1 sine 30, and that'll give us 0.86 F1 in the x direction plus 0.5 F1 in the y direction. So this is the Cartesian vector or Cartesian coordinates for F1. Now we move on to F2, and we want to find these two, the y and the x. We do the exact same thing, except here we need to make sure we're paying attention to directions. So here the x component is actually going in the negative direction. So it's going in the negative x direction. So we do negative 650 sine of 36.87. Why is it sine? Well, because sine is opposite hypotenuse. So in order to find the opposite of the angle, it would be this, right? And then in order to find the y component, we do cosine because it's adjacent hypotenuse. So you need to make sure you're paying attention to when to use sine and cosine. You don't use sine for the y component always, and you don't use cosine for the x component always. So I get F2 as negative 390 x direction plus 520 y direction. And from here we move on to F3. We want to decompose that into the x and the y component. The x component is in the positive x direction, so we just do 500 cosine 45 minus 500 sine 45. We do minus because the y component is going in the negative y direction. And we end up with 353.55 in the x direction minus 353.55 in the y direction. So now we have F1, F2, and F3 in Cartesian coordinates. And if we look back to the problem, it gives us the magnitude of the resultant force, which is 400 newtons. So we have this But then, if we think about it, we have another value for it, because the resultant force is just the summation of all of the forces. So if we sum F1, F2, and F3, we get another representation of the resultant force. And basically what I did is I just summed them normally, but make sure you combine all of the x coordinates together and all of the y coordinates together, so that'll help you do your math, your final math, instead of getting all confused and jumbled. So I combined all of the x components from F1, 2, and 3, and I got 0.866 F1 minus 36.45 in the x direction, and then the y component is 0.5 F1 plus 166.45 in the y direction. And this is all newtons. So now we have two representations of the resultant force. We have the Cartesian coordinate, and we have the magnitude, which was given in the instructions. So what we can do is use the magnitude formula, as stated here, and use this equation to find the magnitude and set it equal to the given magnitude. That way we can solve for F1. So I set 400 newtons equal to the magnitude. Magnitude is square root of x squared plus y squared. So I just found the x and I found the y. So all I do is I just plug them into the formula. I do x squared plus y squared, and then I just do a bunch of algebra, get rid of the square root, factor this out, and then I end up with a quadratic formula. So I have to use the quadratic formula, and once I do that, I just use an online solver. I get the magnitude of F1 to be 313.89 newtons. So this was a pretty involved problem, I would say. You need to make sure you understand the Cartesian coordinates and in order to solve one of the unknowns. And you need to be able to do, if they give you all three of the forces, be able to find the resultant force. So you need to be able to go back and forth. Some tips: make sure you're paying attention to the directions and the signs of the vectors. If they're going the negative direction and the positive direction, make sure you are paying attention to the angles. You're using the correct angle with the correct trigonometric identity. Make sure you know your sine, cosine, tangent. And here's a little overview of the Cartesian coordinate representation.